So good day everyone. So I am Jan Evan Rimaranga and today we are going to discuss three data structure and algorithm. So with that being said, let's dive into our discussion. So a tree is a finite non-empty set of elements. It is an abstract model of hierarchical structure and it consists of nodes with a parent-child relation. So based on the examples here, so the computers are is a parent and its children are sales, manufacturing, and R&D. And also manufacturing is also considered as a parent because it has its own children's too, which 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 are the laptops and the desktops. And the tree has three applications, which are organization charts, file systems, and programming environments. So under the organization charts, trees are commonly trees are commonly used to represent organizational structures where nodes represent individuals and the parent-child relation indicates the hierarchy within the organization. While in the file systems, trees are employed to model file systems on computers, directories or folders, and files can be organized hierarchically using a tree structure. And in the programming environments, trees are utilized in programming for tasks like representing the structure of code, symbols, uh, symbols and syntax trees. So there are two types of trees. So in this picture there are two types of trees. Um, and in this area it is the natural tree, which is our our view. This is what the This is what the tree looks like in the real world. The root is located at the bottom, while the leaves are here and the branches are here. While in the computer scientist view, the roots are located above, while the leaves and the branches are at the bottom. And also it has the nodes which uh, which are located in this area. So, tree terminology. Root. Root is a node without a parent. So in this image, the root here is A because A is located at the top, which indicates that it is the tree's root. Siblings. Siblings are the nodes that share the same parent. So in this part, the siblings are B, C, and D, and its parent is A. And in this case, G and H are siblings, while its parent is letter C. And in this area, E and F are siblings, and their parent is B. And in this area, I, J, and K are siblings, and their parent is letter F. Internal node. Node with at least one children. A, B, C, and F. So because A is considered as internal node because it has because we can consider an internal node when it has its own child. So since letter A has three children which are B, C, and D, A is considered as internal node. And also letter B because it has two children, the E and F. Letter C which also has two childrens, two children which are G and F, G and H, and letter F because it has three children, I, J, and K. External node or the leaf. So node without a children. So external node or a leaf is a node without a children. So in this image, the external node or the leaf are E, I, J, K, G, H, and D. So because E has no children, I has no children, J has no children or it has no child, K has no child, G has no child, H has no child, and so as D. So ancestor of a node. Ancestors of a node is the parent, the grandparent, or grandparent, and etc. So for example, letter I. So its parent is F, while its grandparent is B, and its grandparent is letter A. So that is its ancestor. While the descendant of a node is the child, grandchild, and grandchild. So let's take for an example here. Let's look at the example here, letter A, for example. So its child is letter B, while its grandchild is letter F, and its grandchild are I, J, and K. Depth of a node. So the depth of a node is the number of ancestors. So the number of ancestors here is, so for example, its number of ancestors is 1, 2, and 3. So its number of ancestors are 3. So height of a tree. Uh, the height of a tree is the maximum depth of any node. Degree of a node. The number of its children. So for example, letter C. So the degree of a node A, the degree of the node of the degree of a node of C is 2 because it has 2 children. The degree of a tree, the maximum number of its node. Subtree, tree consisting of a node and its descendants. Edge, edge are the connecting lines of a tree. So these are the connecting lines of a tree. Three terminologies. So property and this part is the property and these are the values. So number of nodes. The number of nodes in this example is 9 because we have 9 nodes here. So if we count it 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this example, we have a total of 9 nodes while its height is 4 because we count its children 1, 2, 3, and 4. So its height is 4. Well, the root node here is the letter A because the letter A is the parent here and it is located at the very top. So in this example, the leaves are D, H, I, F, C. So it is considered as leaves or external nodes because it has no child. Interior nodes. The interior nodes are A, B, E, and G. So it is considered as interior nodes because letter A has its children, B has its children's B has its children which are D, E, and F. E also has its child, the G, and the G has its two children, the H and I. So the ancestors of H. So the example in the image here, the ancestors of H are G, E, B, and A. So the descendants of B. Descendants of B is D, F, E, G, H, I. So D is considered as descendants of B because it is its own child. E is also considered because E is a child of B and also F is a child of B. And G is also considered as descendant of B because it is a child of E, which means that which means that B is the grandparent of G. And also the H and I are also considered as descendants because it is the grandchild of letter B. Siblings of E. So the siblings of E is F and D because the three of them shares the same parent, which is letter B. Right subtree of A. So the right subtree of A is letter C because it is located at the right side, which is here. And the degree of this tree is 3 because so types of tree. So the first one is the general tree. If no constraint or rules is placed on the tree's hierarchy, a tree is called a general tree. Every node may have infinite numbers of children in general tree. The tree is the superset of all other trees. So, a general tree is a tree that is termed a general tree when no specific constraint or rule is imposed in its hierarchy. And its characteristics are each of every node in a general tree may have an infinite number of children. And general trees encompass a broad category and are considered the superset of all other types of trees. So which means it is considered as the superset of all other types of trees. The second one is the binary tree. The binary tree is the kind of tree in which most two children can be found for each parent. The kids are known as the left kid and the right kid. So, a binary tree is a type of tree where each parent which where each parent node can have at most two children. Its characteristics are each node in a binary tree has at most a left child and a right child. So it only has two children, which are the left child and the right child. The left child and the right child are distinct and ordered. And the third one is the binary search tree or the BST. Binary search tree or BST is a binary tree extension with several optional restrictions. The left The left child value of a node should in BST be less than or equal to the parent value, and the right child should always be greater than or equal to the parent's value. So in the BST, a binary search tree is an extension of a binary tree with specific constraints. Um, in a BST, the left child value of a node must be less than or equal to the parent value, while the right child value must always be greater than or equal to the parent's value. Um, this ordering property facilitates efficient search operations. Next slide. So, binary tree. Binary tree is with the following properties. Each internal node has at most two children, the degree of 2. The children of a node are an ordered pair. We call the children of an internal node left child and right child. Alternative recursive definition, a binary tree is either a tree consisting of a single node or a tree whose root has an ordered pair of children, each of which is a binary tree. So as we can see here, um, the root A has only two children, which are B and C. The B has only two children, the D and E. The C has only two ordered children, the F and G. And the E has two children, the H and I. So as we can see, the left side, which is D, is lesser than the B. And the E, and the right side is, where's the cursor? And the E is greater, in the right side, the E is greater than the parent's value, which is B. So a binary tree is, so all in all, the binary tree is defined by the following properties. Each internal node has at most two children, meaning the degree of each internal node is at most 2. The children of a node are treated as an ordered pair. So they are called an ordered pair because, as we can see here, they're ordered D and E. So in an alphabetical order, so they are in line. So D, the next letter is E. F, in the alphabetical order, the next letter of F is G, and so as H and I, and B and C. So the BTS, or the binary tree traversal. A binary tree traversal is a specific order in which to trace the nodes of a tree. So a tree traversal refers to a specific order in which the nodes of a tree are visited or traced, um, and it involves systematically exploring the nodes of the tree in a particular sequence. And there are three common tree traversals. So there are three common tree traversal methods, each with a distinct order of visiting the nodes. So in order, pre-order, and the post-order. So in the pre, so in the pre, and so the in order, um, nodes are visited. Nodes are visited in the order of left subtree root and then the right subtree. The left the left subtree, the root, and the right subtree. In the pre-order, nodes are visited in the in the or in the order of root, left subtree, and the right subtree. In the post order, nodes are visited in the order of the left subtree, right subtree, and then the root. And so for in order, we must print each subtree's left branch before we print its root. So in the case of in order traversal, the nodes of each subtree's left branch, are printed before the root of that subtree. This sequence ensures that the left subtree is fully explored before moving on to the root. And um, and note, pre and post refer to when we visit the root. So meaning the terms pre and post in pre-order and post-order refer to when the root is visited in the traversal sequence. In the pre-order, the root is visited before the subtrees. In post-order, the root is visited after the subtrees. So here are the example of the binary tree traversal. So in this image, the in order, which has the left root right pattern is 3, 5, 6, 7, 10, 12, 13, 15, 16, 18, 20, and 23. While the pre-order in this image, which has the pattern that starts from the root, traverse to the left subtree, and traverse to the right subtree, which are the 15, 5, 3, 12, 10, 6, 7, 13, 16, 20, 18, and 23. While the post order, which has the left-right root pattern, it has 3, 7, 6, 10, 13, 12, 5, 18, 23, 20, 16, and 15. So that's that's all, and I hope that you have learned a lot in my discussion. Thank you for watching.